In every vehicle there are rotating shafts. The crankshaft converts the piston's vertical action into the circular motion that drives the wheels. At the same time, the camshaft turns to open and close airflow valves. These precision parts are behind every successful startup. A life on the road can be tough, and a good crankshaft has to keep on turning when the engine is under stress. The crankshaft starts with a forged steel shape. A computerized blade shaves off excess metal from sections called counterweights. They offset the load of the engine's pistons and connecting rods, and this process slims them down to create a balance. A computerized drill bores holes into one of the bearings to reduce the overall weight. Next, a worker removes marks the computerized tools have left on the metal. He sands the entire crankshaft. The surface must be completely flawless for it to operate smoothly. Fine glass beads blast the part as it revolves in a rotisserie-like device to knock off sharp edges and give the crankshaft a consistent finish. The crankshaft then spins in a lathe as a blade slices away a precise amount of metal from each of the counterweights. This machining provides enough clearance for the engine's pistons and rods to function. The crankshaft then takes another spin in a device that has sensors to detect any imbalance. It calculates that just over 29 grams of metal still needs to be removed. Once the adjustment has been made, he measures the degree of straightness. If it's off even slightly, he corrects it by applying pressure with a press and tapping a special radius chisel. He then measures again to confirm he's done an even job. On the left is a crankshaft that hasn't been balanced or straightened. On the right is one that has. Production now moves to the engine's other rotating shaft, the camshaft. Machining transforms a steel billet into the basic shape. Like the crankshaft, this camshaft will need a lot of fine-tuning. An automated tool first etches the part number and date onto one end, and then they get down to the precision work. The camshaft must also be completely straight, so the technician measures it from one end to the other and makes adjustments where needed. Next, he selects a master template of a camshaft lobe and places it in a grinding machine. This master is the pattern to be copied by a grinding wheel. Once it's been locked in place, he activates the grinder. It carves into the camshaft as it rotates and rocks back and forth in the machine. The grinding wheel moves down the camshaft to shape all 16 lobes to the exact contours of the template. This is how the camshaft looked before the master grinding and after. Next, a computerized probe measures the profile of each lobe and confirms that the dimensions and lift are identical. At the next station, the camshaft spins to allow a worker to completely coat the journal bearings with a blue dye. The dye masks the bearings to keep them smooth, while the rest of the camshaft is being parkerized. Parkerizing will give the camshaft an etched finish, which protects against wear. They start with a quick rinse. Then they plunge the camshafts into hot phosphorus acid. The acid microscopically etches the metal, while other chemicals in the bath add a thin graphite coating. They rinse the residue. After the finish has dried, a worker buffs the journal bearings as the camshaft spins. This completely rubs off the blue dye and polishes the metal. He then wipes down the entire camshaft with a dry rag. He places the camshaft on a perforated metal shelf and floods it with oil. Some oil drains away, but a residue clings to the part, and that residue will prevent rusting. Once packaged, this rotating shaft is on its way to a garage or car factory, where ultimately it will do its part to help set the wheels in motion.